Welcome to STEM Tutor. So here is the first episode of Earth Science with RJ. So today we're going to be talking about minerals. So minerals are defined as naturally occurring inorganic solid with a definite chemical composition and an ordered internal structure. Every mineral is unique, but they exhibit these general characteristics. So minerals are generally classified into 7 compositions. As you can see from the pictures here, we have quartz to represent the silicates. Silicates are composed primarily of silicon oxygen tetrahedrons. We have magnetite to represent the oxides, which consists of metal cations bonded to oxygen anions. So we have pyrite to represent sulfides, which is a metal cation bonded to sulfide. We have andesite to represent the sulfates. Sulfates are metal cations bonded to sulfate. So we also have halite or rock salt to represent the halides, which is composed of a halogen ion, which again forms halite or rock salt. We also have calcite to represent carbonates, which is the presence of carbonic ion which bonds elements such as calcium to form calcite. And lastly, we have gold to represent the native metals, which just consists of a single metal. So to proceed, we have crystal structure of the minerals. So crystal structure is dependent on the chemical composition of the minerals, and similar chemical compositions often share the same crystal structure and generally belong to the same crystal system. So there are 6 crystal systems. There is isometric. Isometric is when there are 3 axes and they're all equal and they form right angles. So we also have hexagonal. Hexagonal is it has 3 equal lateral axes and they all form right angles to a vertical axis. We also have tetragonal, which consists of 3 axes and the 2 lateral axes are equal. So we also have orthorhombic. These are 3 unequal axes, but they form right angles. And we also have monoclinic. Monoclinic has 3 unequal axes, and it has 1 oblique intersection. And we also have lastly triclinic, which just consists of oblique angles, 3 oblique angles from the 3 axes. So next, we're going to proceed with the physical properties of minerals. So these physical properties are useful for identifying minerals using a systematic method such as data classification. I won't go too deep, but this just means that these physical properties help in just to see what kind of mineral is it just by looking at it. So let's proceed. We have habit. So habit is the shape of how a mineral tends to form. So as you can see from the pictures here, different minerals have different habits on how they form. So like their outer shape, the shape of how, if you see a mineral, sometimes they have tablet or flat shapes, or maybe sometimes they look sharp. So that's the habit of a mineral. So we also have cleavage. Cleavage is when the mineral breaks with smooth edges or surfaces. So as you can see, cleavage is more of cleavage actually corresponds with fracture, wherein the mineral breaks with jagged or rough surfaces. So the main difference between cleavage and fractures are just basically what happens to the minerals after it breaks. So if a mineral breaks and it has smooth edges or surfaces, then that's cleavage. But if it breaks with jagged or rough surfaces, you can call that a fracture. So next, we have luster, the appearance of light as it is reflected off its surface. So basically luster, again, by its definition, it's basically what the mineral will look like once light is reflected on it. Does the light seem shiny like metallic surfaces, or does it seem more like non-metallic? As you can see the pictures here, show you different kinds of luster based on the appearances of light. But in general, luster is classified as either metallic or non-metallic, and yeah, basically that's it about luster. So next we have color. So let's start with streak first. So streak is basically the color of a mineral in its powdered form. So the only way to get the streak the easiest way to get the streak of a mineral is by using a streak plate. So what happens is you rub the mineral on the streak plate, and then the color it leaves on the streak plate tells you what the streak is of the mineral. So basically that's the color of the mineral in its powdered form again. So and then again we also going back, sorry. So the difference with streak compared to color is that color is actually not so reliable because it can be altered by chemical impurities within its structure. And although color again is the most obvious, it's not reliable because of that. So it's actually much better to rely on streak since its powdered form isn't necessarily altered by the chemical impurities within its structure. So next we have the Mohs hardness scale. So basically, the Mohs hardness scale is used to determine the hardness of a mineral. So the hardness of a mineral is actually it's the hardness of a mineral is the strength of the chemical bonds in its structure. So using the Mohs hardness scale, this can be determined by scratching a mineral with another mineral. So as you can see from the picture table here, you can see that diamond has the highest scale. So the way the Mohs hardness scale works is like, for example, if you want to see if a mineral is hard, it has a hardness number of 4, you have to see if that mineral can be scratched by fluoride. If it can't be scratched by fluoride, then it has a higher it's harder than fluoride, and it ranks higher than 4 in the Mohs hardness scale. But if it can be scratched, that means it's much lower than the mineral. So the way you can use the Mohs hardness scale is either by testing which minerals let's say the mineral you wanted to test. In order to determine its hardness, you can test it by testing which minerals it can scratch and which minerals can scratch it, and that's how you know its hardness, the level of its hardness. And lastly, we have density. So density is the mass of a mineral divided by volume of the mineral. So specific gravity is a measure that's usually used here, and most common minerals have a specific gravity of 2.7, while gold generally has the highest at about 19. So the way this can be measured is by you put a mineral in water. You measure water, for example, you measure water, let's say at around, let's say 100 ml or 50 ml, and then if you put the mineral in it, then it rises to 67 ml, let's say. You can say that the density is more, the volume of the mineral is at around 17. So then what you're gonna do is you're gonna get the mass of the mineral, and then you divide it by 17, and that's how you get the density. So this concludes our introduction to minerals. Again, this has been Earth Science with RJ. Stay tuned for more. If you have any questions, feedbacks, leave it in the comment section. I'm very willing to entertain questions related to your Earth Science. So this has been a very pleasant experience. So please let us know what else we can do to be better. So thank you. Again, this is STEM Tutor RJ out.